So looking at question 3, we have the question, the equation for the magnitude of the gravitational field strength due to a point mass may be written as y is equal to kx over s squared. The equation for the magnitude of the electric field strength can be written in the same form. In the table, identify the symbols used in the equation. So let's just go back to my actual formulas from the data booklet. If I use these two formulas, this G is your gravitational field strength. It's equal to the force divided by the mass, and the force of gravitation between 2 point masses is given by this formula here. So if I replace my F by that, you can see it's force divided by mass. So one of these masses are going to cancel out the mass where you're measuring the field strength. So it's going to be big G m over r squared. And we can do the same thing here, that this force here due to your electric field strength will be able to replace that, and so we would have the Q, or cancel one of these Q's, and so get KQ over r squared. So here we're going to have, this is going to be the gravitational field strength. It's going to be G, the gravitational field strength. I'll just write Fs there, and here this will be the electric field strength there. K is your gravitational constant, and G is for the gravitational field quantity, and here it's going to be your Coulomb constant. Your X, this is the mass, and this is the charge of the field that we're finding the field strength of, and this is the distance, and also the distance to the center of the charge, or the center of the mass. Good. So looking at B, the magnitude of the electrostatic force between the proton and electron in a hydrogen atom is Fe. The magnitude of the gravitational force between them is Fg. Determine the ratio Fe over Fg. So we're going to have Fe is going to be, I need to get my constant, so let me go back to my start here, get our constants. So we've got those. Here they are. So we're going to have, for this, let me just actually just move this up here. So I can see them all. So I'm going to have Fe is going to equal K, and K is equal to, it's this one over here, your Coulomb constant. It's going to equal 8.99 times Q1, and this is the elementary charge. Now this is the charge on both the proton and the electron. One is positive and one is negative, so it's going to be 1.6 times 10 to the negative 19, and it's going to be squared. We're going to have that squared, and we're going to divide it by the radius squared, the distance between the proton and the electron. And then we're going to divide it here by Fg. Now when I divide a fraction, obviously I invert in times. So I can say times, and I can do big G, which is this one over here, 6.67. Sorry, I won't do, when I divide, obviously I'm going to invert in times. So at the top I will have my r squared, which will be the same distance, because we're looking at between a proton and the electron, so it's going to be r squared. And at the bottom here I'm going to have 6.67 times 10 to the negative 11 times, and here I'm going to have my rest mass of an electron, 9.1 times 10 to the negative 31 times, and the rest mass of a proton, which is about 1.7 times 10 to the negative 27. Now we see that our r squares will obviously cancel out, so I'm going to have this. So let's calculate that. So we can have 8.99. Oh, I left out something here, sorry. Times 10 to the 9. Here we have, this is times 10 to the 9. So that's exponent 9 times, I'm going to have 1.6 exponent minus 19, and then I'm going to square that. Now I really need to put the whole thing in divided by, and I'm going to put this into brackets. 6.67 exponent negative 11 times 9.1 exponent negative 31 times 1.7 exponent negative 27, close brackets, enter, and I get something like 2.23 times 10 to the 39. So the ratio of the forces is huge. You've got something like 2.23 times 10 to the 39, the ratio that the force due to the electric field in comparison to the force due to the gravitational field. There's a huge difference in that force.